Hello everyone, welcome to my channel CISC Topper Classes. Today we are going to discuss Chapter 7 Ratio and Proportion of Class 10 M.L.aggarwal. So let us start solving this exercise 7.2 question number 22 to 23. Now let us solve question number 22 here. We have to prove that ABC are in continued proportion here. So firstly we will let here A by B equal to B by C, that is equal to K. So from there we can write in place of A in the LHS part, if we solve here to prove, so it will become A will become as BK plus B divided by B will become CK plus C. Like that only we will solve. In place of B we can write CK again, so CK square plus B will become again CK, then CK plus C. We will take common as CK. So here it will become K plus 1 divided by again K plus 1. This will be cancel out. C will be cancel out equal to K. If we take the RHS part here, that will become A square B minus C divided by B square A minus B. In place of A we can put BK ka whole square. In place of B CK minus C divided by B will become as CK ka whole square. A will become as BK minus B. Then again it will become B square K square CK minus C divided by C square K square BK minus B. Then this will be cancel out. In place of B square we can write as CK ka whole square. In place of CK then minus C divided by C square upon BK minus B. So in place of BK minus B we can put here CK, so CK ka whole square, then CK minus C divided by C square. B will become as CK ka whole square minus CK, then it will become C square K square CK minus C divided by C square, and if we take C and K as common here, so that will become K minus 1. Here also C we can take common, so it will become C cube K square, and here K minus 1 divided by C cube K minus 1. So this will be simply cancel out. K will be cancel out. C cube will be cancel out. We will get equal to K. So here LHS is equal to RHS in this part. Hence proved from here that ABC are in continued proportion in question number 22 first part. Solve question number 22 second part. If we take ABC and are in continued proportion, A by B and B by C equal to K. So in the LHS part, left hand side we can put the values. 1 by A cube will become 1 by BK ka whole cube. Then plus 1 by B cube will become CK ka whole cube plus 1 by C cube. So it will become 1 by B cube K cube plus 1 by C cube K cube plus 1 by C cube. So that will become as 1 by B cube K cube also we can write. So in place of B cube it will become CK. So 1 upon CK ka whole cube K cube plus 1 upon C cube K cube plus 1 upon C cube. So it will become here 1 upon C cube K की power 6 plus 1 by C cube K cube plus 1 by C ka cube. So in the RHS part again we will put the values and solve like this only. So it will become A by B square C square plus B by C square A square plus C by A square B square. So in place of A here we can put BK. So BK upon B square will become CK ka whole square C square. Then again plus B upon C square A square. So B will become CK upon C square A square will become C square BK का whole square plus C upon A square will become BK का whole square and B square. That will become as BK divided by C square C की power 4 K square plus CK upon C square B square K square plus C upon B square K square B square. So it will become B will become as CK square upon C की power 4 and K square. C की power 4 K square plus CK upon b will become ck ka whole square, so c ki power 4 and k ki power 4 here also. Like this, b square again we will put c square k square, so c square k square into k square again c square k square here. So if we put the values here, it will become ck square upon c ki power 4 k square plus ck upon c ki power 4 k ki power 4 plus c upon c ki power 4 and k ki power 6. So this will be cancelled out by one power. Here c ki power 4 will be cancelled out by c ki power 4, c with c ki power 4, then k with k ki power 4, again c with c ki power 4 and k square with k square. So it will become 1 by c cube plus 1 by c cube k cube plus 1 by c cube k6. So this will be equal to, the RHS part will be equal to the LHS part here in this question. So from there we have proved, hence proved that ABC are in proportion in this question. ABC are in proportion in this question. Let's solve question number 22, third part. Here again a by b is equal to b by c, which is equal to k. So we can put in place of a as bk. So a by c will become bk upon c equal to a square plus b square will be bk ka whole square plus b square divided by b square will become ck ka whole square. B square will become here ck ka whole square, and ck ka whole square, b square will become ck ka whole square plus c square. So we can write it as, again we will put in place of b as ck. So ck square upon c equal to b square k square plus c square k square upon c square k square plus c square. This will be cancelled out in the LHS part here, and this is the right hand side. So this will be, on solving, it will become k square taking common b square plus c square upon here again c square we can take common. We will put the values here, c square k square plus c square. So if we put in place of b square, it will become k square ck ka whole square plus c square divided by c square k square plus c square. So it will become, on solving, k square then c square k square plus c square divided by c square k square plus c square. So it will become as c ki power 2 and k ki power 2 will become um, k ki power 2 only we will take. So k ki power 2 plus 1 divided by c square, if we take common, that will become k square plus 1. This will be cancelled out and it will be equal to k square. So LHS is equal to RHS in this question, hence proved from this question. Hence this is the solution of question number 22, third part. Let's solve question number 22, fourth part here. Again a by b is equal to b by k, b by c equal to k. We will put the value in the left hand side here. A will become as bk ka whole square, then b square ck ka whole square, c square a ki power minus 4. So a ki power minus 4 will be bk ki power minus 4 plus b will be ck ki power minus 4 plus c ki power minus 4. So it will become as b square k square c square k square and then c square. It will become 1 by bk ki power 4 plus 1 by ck ki power 4 plus 1 by c ki power 4 here. So on solving, we will get b square c ki power 4 k ki power 4 upon 1 by b ki power 4 k ki power 4 plus 1 by c ki power 4 k ki power 4 plus 1 by c ki power 4. On solving this, we can take LCM b square c ki power 4 k ki power 4, and here we can take LCM as b ki power 4 k ki power 4 and c ki power 4. So here we will get c ki power 4 plus b ki power 4 c ki power 4 and k ki power 4, then plus b ki power 4 and here c ki power 4. So b ki power 4 and k ki power 4. This will be simply cancel out here, b ki power c ki power 4 and k ki power 4, and this will be somewhat cancel out by power 2. So we will get as c ki power 4 plus b की power 4 plus b की power 4 and k की power 4 upon b की power 2. C की power 4 we can write it as C की power 4 only, B की power 4 CK की power 4 plus B की power 4 CK की power 4 and then K की power 4 divided by B square. So C की power 4 plus C की power 4 K की power 4 plus C की power 4 K की power 8 here divided by B square. So we can take common 1 plus K की power 4 plus K की power 8 divided by B square will become C square and K square. This will be cancel out and we will get 1 plus K की power 4 plus K की power 8 divided by K square. Like that, if we want to solve the RHS part also, so we can write A की power 4 plus B की power 4 plus C की power 4 divided by B की power 2. In place of A, it will become BK की power 4 plus CK की power 4 plus C की power 4 divided by B square. Again B की जगह हम CK की power 4 रख सकते हैं, तो C की power 4 and then K की power 8 plus C की power 4 K की power 4 plus C की power 4 divided by B square. We can take common here C की power 4 which is K की power 8 plus K की power 4 plus 1 divided by B square will become CK की C square K square. This will be cancel out and it will become C square. Here it will become C square. It is left here also. So we will write C की power 2. Here also it is becoming. So it will become K की power 8 plus K की power 4 plus 1. Here this will be the C की power square, which is equal to the RHS part here, right hand side. So we can write if LHS is equal to RHS in this question, hence proved that ABC are in continued proportion in this question. Hence proved. And this is the solution of question number 22, fourth part. Let us solve question number 5 here. If we solve here, where A by B is equal to B by C equal to K. So A will become as B into K dot C into K dot C. Then A will become, this is the left hand side we are taking. A will become as BK plus CK plus C का whole cube. Again in place of B will put the value CK square. So CK square dot CK dot C. Then B will become CK square plus CK plus C का whole cube. Taking C cube K की power 3. Then here it will become CK square plus CK plus C का whole cube. We can take common here C की power cube. So C cube K cube. On taking common here C की power cube. This will be K square plus K plus 1 का whole cube. C की power 6 and K की power cube. K square plus K plus 1 cube we are getting in the LHS part. If we solve for the RHS part here, that is AB plus BC plus CA, by putting the value here also, A will become as B into K. So B square K plus B will become C square K. And then again A will become BK. So it will become C dot BK ka whole cube. Again B square will become C square K की power C square K square, then K की power cube plus C square K plus C. B will become as CK. So C square K की power C square CK. Here it will become C square K square का whole cube. Now we can take common in place of that. C की power 6 we can take common from here. So C की power 6 K cube plus K square का whole cube. Again here also we can take common K cube. So on taking common K cube we will get C की power 6. K we will take common from there. So it will become K cube this side. K square plus 1 plus K का whole cube. So LHS is equal to RHS, hence proved that ABC are in continued proportion in question number 5 of 22 question. And this is the solution of this question. Let us solve question number 6 here. So it will become A by B is equal to B by C equal to K. So it will become A in place of A, it will become BK plus CK plus C, and here it will become BK minus CK plus C. So in place of B, we can write CK ka square plus CK plus C. Here again, CK square minus CK plus C. Taking common, it will become C as common, K square plus K plus 1. Then again K square is common. Then it will become, sorry, C we will take common again. So it will become K square minus K plus 1. So it can be written C square, K square plus K plus 1. And here K square minus K plus 1. Again for solving, this is the LHS part we have solved here. If we solve the RHS part here in this question, so it will become A square will become BK ka whole square plus B square CK ka whole square plus C square. In place of B again CK, then CK K का whole square plus CK का whole square plus C square. So it will become C square K की power 4 plus C square K square plus C square. Taking common here C square, it will become K की power 4 plus K square plus 1. This is forming a formula only. So this is also the formula K की power 4 plus K square plus 1. Hence proved that LHS is equal to RHS as ABC are in continued proportion. Hence proved LHS is equal to RHS in this question. This is the solution of question number 22, sixth part. Let's solve question number 23, first part. If we solve ABCD are in continued proportion, so AB by BC equal to C by D is equal to K. So we will solve the left hand side here. It will become A cube will become BK ka whole cube plus B cube will become CK ka whole cube plus C cube will become DK ka whole cube divided by B cube will become CK ka whole cube plus DK ka whole cube plus D cube. So that will become B cube K cube plus C cube K cube plus D cube K cube divided by C cube K cube plus D cube K cube plus D cube. So in place of B, it will become C cube K cube dot K cube plus C cube will become D cube K की power 6 plus D cube K cube divided by D cube K की power 6 plus D cube K cube plus D cube. So here we can write in place of C cube as DK ka whole cube. So D cube K की power 9 plus D cube K की power 6 plus D cube K cube divided by same thing D cube K6 plus D cube K cube plus D cube. Taking common here D cube and K cube, it will become K की power 6 plus K की power 3 plus 1 divided by D की power 3. It taking common K की power 6 plus K की power cube plus 1. This will be simply cancel out. This will be cancel out. It will become K cube. So if we take the RHS part here, A by D. A by D can be written as BK divided by D, and D will become as B will become as CK. So CK square divided by D, and here C will become as DK cube divided by D. So LHS is equal to RHS, hence proved that ABCD are in continued proportion in this question, and this is the solution of question number 23, first part. Now let us solve question number 2 here. Here we have to prove that ABCD are in continued proportion. So in place of A, we can write it as DK cube ka whole square minus DK square ka whole square, like this here also. And in solving, D square K की power 6 minus D square K की power 4, D square K square minus D square. Taking common D square K की power 4, it will become K square minus 1 this side. And taking common D square K square minus 1, it will become D की power 4 K की power 4 into K square minus 1 का whole square. And in RHS part, it is B square minus C square का whole square dk square का whole square minus dk का whole square का whole square. So it will become d square k की power 4 minus d square k square का whole square. D square k की power 2 we will take common. So it will become k की power 2 minus 1 का whole square. So this is only we have to prove. So LHS is equal to RHS in this question. Hence A, B, C, D are in continued proportion. And this is the solution of question number second part of question number 23. Let us see question number 3 of 23 question. Here A plus D, B plus C minus A plus C, B plus D is equal to B minus C ka whole square we have to prove. So again we have to prove that A, B, C, D are in continued proportion. So A by B is equal to B by C equal to C by D equal to K. So in place of that we can write A as uh, d ka whole dk into cube plus d, and again here also b we can write it as dk ka d into k ka whole square plus dk minus dk cube plus dk square plus d. We have converted all the terms in the form of dk. So here we can take common as d and k. So it will become k plus 1 k cube plus 1. We will cross multiply here k cube plus 1 and k plus 1. We'll multiply them and we will get d square k as k cube minus 2k square plus k, and d square k square as k square minus 2k plus 1, where d square k square will become k minus 1 ka whole square. B minus c ka whole square will become dk square minus dk ka whole square. D square k minus 1 ka whole square. So here LHS is equal to RHS in this question, hence proved from here. Hence proved that A, B, C, D are in continued proportion in question number 3. Let us solve question number 4th part of this question 23. So A by D will become as dk cube upon D. So D will be cancelled out in the LHS part. If we solve the RHS part here, that will become A minus B ka whole cube upon B minus C ka whole cube. So in place of A, it will again become dk cube minus B will become dk square का whole cube divided by again b, then dk square minus c will become as dk का whole cube. So we can take common as d cube, and here k cube minus k square का whole cube, d cube k square minus k का whole cube. This will be cancel out. Here we can take common as k. So it will become k cube k square. There we can write it as k square minus k ka whole cube divided by k cube, and it will become k minus 1 ka whole cube. So this will be cancel out and we will get k square minus k ka whole cube divided by k minus 1 ka whole cube. So again we can take common here as k cube k minus 1 ka whole cube upon k minus 1 ka whole cube. From that RHS is equal to RHS in this question. LHS is also k cube and RHS is also k cube we are getting here. As LHS is equal to RHS, we can hence proved that ABCD are in continued proportion. ABCD are in continued proportion in this question, and this is the solution of question number 4th of question number 23. Now let us solve this question here. Again we will write the terms here in the LHS part in dk form. So here dk cube minus dk square upon dk cube minus dk by dk square ka whole square, d minus dk square by dk plus d minus dk by dk ka square ka whole square. It will become dk square is common, k minus 1 upon dk plus dk k square minus 1 upon dk square ka whole square minus d common 1 minus k square upon dk plus d 1 minus k upon dk square ka whole square. Taking common and solving, we will put the terms here in k. So this is in k, and here we can write in the last k cube minus 1 ka whole square into k square minus 1 upon k ki power 4. And if we write the RHS, so again in place of a dk cube minus d ka whole square 1 upon d square k square minus 1 upon d square k ki power 4, d square taking common k cube minus 1 ka whole square k square minus 1 and d upon d square k ki power 4. Cancelling d square will be cancelled out. Here it will become k cube minus 1 ka whole square k square minus 1 upon k ki power 4, which is equal to LHS. Hence LHS is equal to RHS in this question. Hence we can say that A, B, C, D are in continued proportion, and this is the solution of question number 5 of question number 23, exercise 7.2. This is the last solution of the question. Thank you for watching my video. If you like this video, don't forget to like, share and subscribe my channel.